Alright, this lesson we're looking at some application using our linear skills. So only thing that's going to be different using a linear application, we're still following the same relationship that we have, but only difference here would be instead of x and y, we might have different letters to represent different scenarios, but we're following the same idea. So here is a scenario that we're going to look at together. We have a water tank that is 90 liters full, and then it's leaking at a rate of 1.5 liters per hour. And we want to use V to represent the volume of water in the tank, and then T for number of hours. So we know that there's a tank, it's leaking. So there's a little hole here, it's leaking water at 1.5 liters per every hour. And in the tank, it had 90 liters of water to start with. So at some point, it's going to leak all the water out of the tank. So what we're dealing with here, we have a variable that's changing. That's the time and how much is leaking. And we, as a response to that, the water level's changing. So the time is determining the water level. So time is going to be our x. Whatever determines the other is always the x, and y is the outcome of it. So this is the outcome. Another way to say this is a response. So y is the response variable, whereas x is the explanatory really hard to write sideways variable. So x always explains the y. So in this case, how many hours will determine how much water is leaking, not the other way around. So x has to be our time. And in this case, we use v for water and t for time. So we are going to follow a relationship that looks like V equals MT plus C. So instead of X and Y, we have V and T in the places that we want it. We know M from the context. M is like how many or what's happening to X or T in this case every time. And this is what's happening. We're losing 1.5 liters of water. So we're losing V. So V is going down at 1.5 rate per hour. And then for our C is the y-intercept. So this is our y-intercept. Right, we already know that. What we also know, y-intercept is when x equal to 0. Now, in our case, x is t. In our case, x is t. So this t here is our x. So think about when t is 0, when time is equal to 0, how much water do we have? Well, at the very start, when there's no time that's passed, we have 90 liters of water. So C is going to be 90. And that's our equation. Our equation follows the same format of this, obviously in this different context that we have. Now, we are asked to graph this equation, and we're asked to graph only between when t is 0 to 60. So let's do that. So we know this over here will have to be V, and this over here is our T. And we want to go up to 60, so maybe we need to go every 2 steps as a 10. Or is that going to be enough? Nope, that's not enough. So 10, 20, 30, 40, 50, 60. Let's do that. 20, 0, 10, 20, 30, 40, 50, 60. And then for V, we know the highest it's going to be is 90. 2, 3, 4, 5, 6, 7, 8, 9. That's enough. So 90 here, 10 here. So it's going up by 10 every time. Yep. We know the y-intercept is at 90. So it's going to start at 90. And then we are going all the way until time is 60 hours. So we need to figure out what that is for in terms of a v. So we know our equation is this. Our equation is v equals 1.5t plus 90. So we need to know what v is when our time is 60. Oops. Yep, like that. And if you use the calculator to put it, or if you do use your head, it's going to be 0. So we know this is another point that we are using. So we have 60, 0, and we have 0, 90 over here. And we draw a straight line, as straight as you can. Mine's not super straight. And that's going to be our graph. And there's a couple more questions we have to answer. Here it says, what is the volume of water after 5 hours? Let's do it over down here so we have a bit more space. Well, we know the volume follows this formula, this equation. So all we need to do, we know t is time in hours, so we just replace t with 5. And then that's going to be negative 7.5, I believe. So 82.5 liters is the volume after 5 hours. And then the next question says, how long does it take for it completely empty the tank? We know when the tank is empty, that means volume is 0. So we know this point happens at where t is equal to 60 hours.